How long do you think it takes to build a 57-story building? 2 years? 3 years? Or perhaps several dozen months? Thousands of workers, concrete trucks, scaffolding, and cranes operating non-stop? In China, a 57-story tower was once assembled in just 19 days. Even more unbelievable, another 10-story apartment building was completed in exactly 28 hours and 45 minutes. And not just the structural frame, the walls, windows, balconies, plumbing, and electrical systems were all installed, like giant building blocks. But is this truly a groundbreaking leap forward, or just a technological illusion? And if everything sounds so perfect, why does this construction method remain so controversial today, as we explore the modular housing and 3D printing revolution that is shaking the global construction industry? Project overview. But in reality, modular housing is not an entirely new idea. Decades ago, East Germany, the Soviet Union, and many European countries had already built large numbers of apartment buildings using prefabricated concrete panels to solve the housing crisis after the war. What China is doing today is not reinventing everything from zero. Instead, it is bringing an old construction principle into the 21st century. Lighter steel modules, more automated factories, stricter quality control, and assembly speeds so fast that they have become controversial. This movement raises a much bigger question. Will the future of construction still belong to traditional construction sites, or has it already moved into the factory? The man shaped by an earthquake. To understand why Broad Group rushed into this revolution, we have to go back to 2008, to the ruins of one of the most devastating earthquakes in Chinese history. Before that moment, Zhang Yue was not a name associated with the construction industry. Broad Group, the company he founded in the city of Changsha, was known as one of China's major HVAC system manufacturers. But on May 12, 2008, a massive earthquake measuring nearly magnitude 8 struck Sichuan, killing around 70,000 people. Schools, hospitals, and apartment buildings collapsed within seconds. Structures that were supposed to protect human lives suddenly turned into enormous piles of concrete, crushing the very people inside them. Zhang Yue looked at that disaster and asked what seemed like a simple question: why are we still building buildings this way? From that moment, he made a decision that many considered crazy. He shifted away from the air conditioning business and redirected his engineers, factories, and production lines toward a single goal: creating a housing system that could be manufactured inside factories, assembled at extremely high speed, rely less on wet concrete construction, and, most importantly, withstand destructive forces like earthquakes more effectively. Construction. Inside the factory, Zhang Yue's answer did not begin with building a larger construction site. It began with moving the construction site into the factory itself. Instead of transporting raw materials to the site and starting construction there, they manufacture most of the building inside a massive factory covering about 230,000 square meters, equal to more than 30 football fields under a single roof. Inside this facility, a building is divided into large modules, almost like giant shipping containers. The walls are already installed inside them, and the floors are already manufactured. Windows, balconies, electrical wiring, plumbing systems, and ventilation ducts are all integrated in advance. Some components can even be folded for easier transportation and then unfolded once they arrive at the construction site. This is what makes Broad Group's method different. On a traditional construction site, each team of workers must operate one after another, meaning that even a small mistake hidden behind concrete or finishing layers can make repairs slow and expensive. Inside the factory, however, everything is controlled like an industrial production line. Each module is measured, assembled, inspected, and approved before leaving the factory. Errors are discovered earlier, quality becomes more consistent, and, most importantly, many stages can happen simultaneously instead of waiting for each step to be completed one by one at the construction site. Installation at the construction site. Once the room modules are completed, the installation process at the construction site begins. Trucks transport each module to the site in the correct sequence. Cranes lift them into the air, Workers align them into position and then use high-strength steel bolts to lock one module to another. One room is stacked on top of another, floor after floor slowly takes shape, and the entire building rises, not by pouring concrete layer by layer, but by assembling pre-prepared blocks of space. If traditional construction is like cooking a complicated meal outdoors, in the middle of wind and rain, where every ingredient must be prepared on site, then Broad Group operates more like an industrial kitchen. Everything is cut, measured, tested, inspected, and prepared in advance. When the time comes, the job is simply to place each piece in the correct position. To prove that its modular system was not just a laboratory concept, the company recorded the entire construction process of a 10-story apartment building in Changsha. The foundation had already been prepared. The modules had already been manufactured inside the factory. The moment the first truck entered the site, the clock started running. One by one, cranes lifted the modules off the trucks, raised them into the air, aligned them into place, and locked them together with steel bolts. The process repeated again and again. After 28 hours and 45 minutes, a 10-story building was standing on the ground. The time-lapse video quickly spread around the world. For many people, it was difficult to believe. A building had risen faster than the time many traditional construction sites need just to complete a single concrete floor. Some engineers called it the future of construction. Others were more skeptical, questioning whether it was simply a carefully prepared demonstration. Broad Group did not respond with arguments. It responded with an even larger project. The next development was Mini Sky City, a 57-story tower around 204 meters tall, containing hundreds of apartments, office spaces, and commercial areas inside. If built using traditional methods, a structure of this scale could take years to complete. But with the modular system, sections of the tower were manufactured in advance inside the factory and then transported to the site for assembly, like a vertical production line. The result was 57 floors completed in just 19 days. After that, Broad Group attracted even more attention with a 26-story residential tower assembled in a little over 5 days, using a construction crew of around 100 workers, a workforce small enough to fit onto just a few buses, yet capable of erecting a structure taller than most apartment buildings in many cities. Steel and the 1,000-year promise. But speed is only the most visible part of the story. What makes Broad Group's system even more controversial is a deeper question. Can a building assembled this quickly really be safe? A building erected in just a few days means very little if it cannot protect the people inside it for decades to come. For that reason, Broad Group shifted its focus towards steel modules. From a mechanical engineering perspective, steel has better ductility than concrete. It can absorb part of the energy from external forces, deform slightly under load, and then distribute those forces through the structural frame and its connections. Because of this, the system may be particularly suitable for regions exposed to earthquake risks. Not only Sichuan, but also places such as California, Japan, Turkey, Indonesia, and the Philippines, where millions of people live in densely populated cities built on geological zones that are never completely quiet. Broad Group has also made an even bolder promise, a structural lifespan of up to 1,000 years. That number sounds almost unbelievable when compared with many modern concrete structures, which are typically designed for service lives ranging from several decades to a little over a century, depending on design standards, environmental conditions, and maintenance practices. The company argues that this is possible because it controls materials and connections from the very beginning. Steel components are processed inside a factory environment. Parts are manufactured with greater consistency, and connections can be inspected and verified before assembly. This is a significant difference from traditional construction methods. In addition, when a concrete building reaches the end of its life, it often leaves behind enormous amounts of waste. Broken concrete, cut, reinforcing steel, formwork, finishing materials, and thousands of tons of debris that can be difficult to reuse. A steel modular system, on the other hand, can be designed with a life cycle approach. Individual modules can be dismantled, refurbished, reused, or melted down and turned into new materials. As a result, the 1,000-year promise is not only about durability, it is also about a different way of thinking about buildings. Instead of being a fixed mass of material that is constructed and then eventually demolished, a building becomes a system that can be maintained, upgraded, replaced, and recycled over time. The truth behind 28 hours. A technology can build homes 30 times faster, last 10 times longer, and produce 90% less waste. Why is the entire world not using it already? The story deserves a more balanced perspective. The figure of 28 hours and 45 minutes easily gives the impression that a building was created from nothing in just over a day. In reality, however, that was only the assembly time at the construction site. Before the first module was lifted by a crane, the foundation had already been completed. Before the first truck arrived, each room had already been manufactured, fitted with electrical and plumbing systems, inspected, and finished inside the factory. In other words, instead of having dozens of construction teams working one after another in rain, wind, dust, and thousands of unpredictable outdoor conditions, Broad Group moved the most complex parts of the process into the factory. There, steel frames, windows, electrical systems, plumbing, and technical equipment can be installed simultaneously in a much more controlled environment. If we look only at assembly time, modular construction is astonishingly fast. But if we consider the entire project lifecycle, from design and module production to foundation work, transportation, assembly, inspection, and maintenance, the picture becomes much more complex. Then there is another question. Does building this quickly create a place where people truly want to live? The history of prefabricated housing has not always been positive. Many projects left behind images of identical apartment blocks, repetitive corridors, and living spaces with little character. If modular housing becomes nothing more than stacking steel boxes on top of one another, it may solve the problem of quantity while creating cities that are fast, cheap, and soulless. And modular construction is not a magic solution to the global housing crisis. Homelessness and housing shortages are also connected to land prices, urban planning, financing, infrastructure, social policies, and housing affordability. A building may be assembled in a matter of days, but the bigger questions remain. Who gets to live there? How much will it cost? And will the city even allow it to be built? For that reason, the debate surrounding the famous 28-hour and 45-minute construction record does not make the technology any less impressive. If anything, it helps us understand what it truly represents. Broad Group did not create a miracle. What they did was change where construction happens, from a chaotic outdoor job site to a controlled factory production line. And perhaps that is the real revolution. 3D printed homes. However, modular housing is not the only path in China's new construction revolution. While Broad Group manufactures rooms inside factories and then assembles them like giant Lego blocks, another, even more ambitious technology is emerging: 3D printed housing. Instead of transporting completed modules to a construction site, this technology uses massive printers to create walls and building components layer by layer. The print head does not spray ink. Instead, it extrudes a mixture of fast-setting cement, crushed bricks, recycled aggregates, and reused construction materials. Guided by a digital design, the machine follows a programmed path, placing one layer on top of another until a complete wall appears. In theory, a building can be printed directly from digital data, reducing manual labor, shortening construction time, and making use of large amounts of construction waste. Companies such as Winsun have already demonstrated houses built using this technology, attracting attention around the world. However, 3D printing is not a perfect solution. A real home requires more than walls. It also needs foundations, roofs, electrical systems, plumbing, waterproofing, insulation, and compliance with numerous safety standards. Questions about long-term durability, earthquake resistance, and structural integration are still being studied. If broad group represents the idea of manufacturing rooms in a factory and assembling them on site, then 3D printing represents a different approach, turning digital designs directly into physical structures. Yet both technologies are asking the same question: will the future of construction still look like it does today? The future of construction. So, will steel modules or 3D printing completely replace concrete? The answer is not that simple. Concrete will not disappear overnight, because what keeps the construction industry tied to traditional methods is not just the material itself, but an entire system that has existed for more than a century. Building codes written around concrete and timber, established supply chains, traditional contractors, and concerns about jobs as construction sites require fewer workers, all create enormous resistance to change. Yet countries such as China, Singapore, the United Arab Emirates, and many others facing severe housing shortages have already begun pushing through that barrier. They are no longer asking whether these technologies should be adopted. Instead, they are asking how quickly they can be scaled. And now, a question for you. If a building could be assembled in 28 hours, withstand a major earthquake, and potentially last for centuries, would you be willing to live in it? Or would you still trust conventional concrete more? Let us know your answer in the comments below, and do not forget to like, share, as we continue exploring the technologies that are changing the world in ways few people ever imagined. See you in the next video.